Okay, today's lesson we're going to be looking at arrangements so we can decide what's the probability of a particular sequence of things coming out. I'm going to talk about a deck of cards and what we can consider as different ways that we can lay out the Jack, Queen and King. I encourage you to actually pause at the moment and think, how many ways could you put the Jack, Queen, King down? So have a think. Trying to think how many ways can you put a Jack, a Queen and a King in the same down. Okay, let's try to list them then, shall we? The first one, obviously, order that's written is to do a Jack, a Queen, and a King. Then next to that, I could actually move the King across one, and to process these things, it's normally easiest to think about moving one piece at a time. So I'm going to move the King to the middle. So the Jack stays where he is, the King moves over, and the Queen must go in the final place. Again, let's keep moving the King across. So now we've got the King, leave the Queen where it was, move the Jack. So that's my first set. In the next lot, I'm going to move the Queen over. So I've got a King, the Queen replaces where the Jack was, and therefore the Jack's been shoved to the right. Move it over once more, the Queen moves the King and the Jack over. And the last one I've got is I've got to move the Jack across one. Queen, Jack, King. Now I've got to the point now where I have actually tried all of them. If I try moving the Jack over again, I'm back to Jack, Queen, King. I've gone through a loop of moving everything one place over, and therefore now I will have exposed it. So with 3 separate items, there are what are called 6 arrangements. Now, it's not often seen in the UK, but it can be written as an A, a funny A, with a 6, either on the top or on the bottom. Sometimes at the front, some at the back, so you could have it written like this. The Russian method seems to often put it 6 below or the 6 in front. So these are the arrangements of 6 items. And if you've got 3 different things, there will always be 6 arrangements. The question is, how many arrangements are there for different sets of cards, different numbers of cards? So each time I'm going to ask you a little question. Let's consider just a letter A. How many ways can I write the A down so that it actually is different to the ones before? Well, there's 1. So the arrangements of A of one item is 1. The next one is we've now got A and B. And the thing to think about this is take the answer before and think, where could B be put? Well, B could go before the A or after the A. So that means that I take the 1, the number of ways of arranging the A, and there are now 2 places I can put a B. So B can go into 2 places. And that gives me 2 methods, or two arrangements. Let's go again. I've now got A, B and C. The A and B we've copied from before. So we now have, so that was the arrangements of A. Now the arrangements of A and B is the 2 times the 1. And how many places could I put C? Well, C could go before the A, before the B, but after the A, or after the B. So there are 3 places that C could go. So C can go in 3 places. That gives me 3 times 2 times 1. like we've seen, that's 6. Let's try one more. Not likely to see much more than maybe, we'll go 2 more actually. Let's do A, B, C and D. A, B, C and D. First of all, the ABC part we've dealt with before. ABC comes from 3 times 2 times 1. Yes, is 6. And the D is how many places could I place D? Well, the D can go in front of the A, between A and B, so between B and C, and between C after the C. So that gives me 4 places. This actually says D can be in 4 places. The 3 times 2 times 1 gives me the different ways that A, B and C can be arranged. So by combining these 2 things together, what I've actually combined is the 4 places D could be, and then the different arrangements of A, B and C. And the effect of that is I could have 24 different ways of arranging A, B and C. Let's do one more. I've now got A, B, C, D, E. See the pattern. How many ways are there of arranging the A, B, C, D? Which is 4 times 3 times 2 times 1. And in front of that, we've got an E, which is how many places could the E be before the A, between B and A, between B and C, between C and D, and after the D. So there's 5 places E could be in. And that gives me 5 times 24, which is 120 different ways of arranging A, B, C, D in E. So with 5 items, you can see the numbers get very big fairly quickly. And there is a common way of writing this. This pattern here, you may have come across it before. This pattern is called factorial. And what it means is, if you multiply all the integers from one number going all the way down to 1, it can be written as 5 with an exclamation mark after it. And when you see the exclamation mark, it says do 5 times all the numbers less than that down to and including 1. So the line further up, this was actually 4 factorial is 24. Go up it again, 3 factorial is 6. 2 factorial is 1. And 1 factorial is 1. Sorry, 2 factorial should be 2. So this is how many ways that you could arrange those letters. And you might get offered questions on this. I'm not going to go into the full details of the next steps too much beyond this, but there are further steps to do with what if some letters are repeated. So the letters are repeated, it reduces the number of ways these letters can be combined. But we've got the words there. So just a little aside, you might want to think, if there is nothing, no, if there's 0 things, how many ways are there of arranging nothing? How many ways can that be arranged? And there's a logical but slightly surprising answer to it. Well, you can't say none, because that's not an arrangement. You haven't got any arrangements you've got. You could have an arrangement of empties. And that's where mathematically we take the meaning. 0 factorial says How many ways can I arrange nothing? Well, the ways of arranging nothing is to have nothing. It's an empty set. But there is one way. It's sort of an interpretation. As we go through further mathematics, this 0 factorial is 1 is extremely important. So it's one of those things where there's a little bit of a funny position. Now, you might ask, why am I showing you these? Well, they might ask us things like, how many ways, or list the ways the letter, how many ways are there to list the letters CAT, cat. And so we've got alphabetical order, ACT. We have ATC. Doing my same trick, I'm keep moving the last one across until it gets to the front, and I'm not repeating. So T moves to the front, A and C have both shifted over. Now go through the test again. C moves over, which bumps A to the end. And if I move the C to the front, I'm left with one other option, which is CAT. So that gives me 6 arrangements. And so they might ask the probability. What's the probability of getting the word cat? Well, how many ways are there of getting the word cat? 1. So how many things are there that could have happened? 6. 6, because it is 3 factorial. So the probability of getting the word cat is 1 out of 6. If you've got 3 cards and you randomly lay them down, what's the probability of getting the word cat? Now, these wordplay games, they can become a little funny. And think carefully. Here's a little question for you. What is the probability that from 3 letters, if I draw 3 cards randomly from birds, A, C, R, there's my 3 cards. What's the probability then I can spell a word? So what's the probability that from the letters A, C, R, I can spell the word? I'm sorry about the jump, but when I was putting the pause button in, there was a problem. There is a caution in this. Do think about it. Well, we know 3 different letters. The organisation is out of 6. So you need to try them and see which ones actually spell words. So let's do the same thing. Let's do a quick list. What words are there that can work in here? So we'll start with the ACR. Move each letter over. So I've got ARC. Move it over again, RAC. Now I've exhausted the positions for R. Let's move the C's. RCA and CRA. CRA. How many lines should I have? I should have 6. I've only got 5, so there's another possibility. If I move the A over, I've got C-A-R. How many of those are actual words? Acre? No, that's not a word. Arc? It is part of a circle. The circumference around the circle, it's part of that. RAC? Not a word, but although it is the Royal Automobile Club in the UK. RCA? No, that's not a word, but it is the acronym for an old radio manufacturer who also used to make records. CRA? Not a word, but car is. So the probability of a word from the list of possible outcomes is 2 from 6, which you could simplify to be 1/3. But like I mentioned before, in unsimplified fractions carry more meaning. It says that there are 2 words out of 6, which is possibly a bit clearer than if you turn around and just did the numbers. There's an exercise to go off and do, and I've got a research homework I'd like you to think about, and think in terms of people having random birthdays.